Hey everyone, this is Mr. Longo, and this video is going to cover arithmetic series. And what we're going to be doing with an arithmetic series is finding the sum of an arithmetic sequence, okay? That's what we're going to be doing here. So to find the sum of an arithmetic sequence, what you need is how many terms there are, and then you just need to take the average of the first term and the last term and multiply those guys together, and you're good to go. So there's a couple of different formulas you can use. Basically, it's where do you want to put the divide by 2. You can divide the number of terms by 2, or you could take the average of the first and last term. So the divided by 2 would go on the inside or underneath the end. Doesn't matter. Pick a formula you like and go with it. So really, we're ready to just begin, because all you need to do is find some of the information, which is the number of terms, the first term, and the last term. So it's actually pretty easy to do. So the first example, we see that we have k is equal to 1, and we have 20 terms. So the first thing we should do is find a sub 1. So that's just going to be 3 times 1 plus 7, and that guy is going to end up giving us 10. And then we need to find the 20th term, because that's where we're going to stop. So that would be 3 times 20 plus 7. And of course, that guy's going to give us 67. Okay, so now to find the sum of those 20 terms, we're just going to use the formula. So the sum of 20 terms is equal to the number of terms, 20 divided by 2, times the sum of our two terms, 10 plus 67. All right, so then that's going to give us 10 times 77 is 770. All right, that's it. That's all you really need. So you need the first term, the last term, and how many terms you have. All right, and that's it. So why don't you pause the video and try the next one, see if you can get it correct. So you should have found the first term, a sub 1, is going to be 1 squared plus 1. So that guy is 2. And we're going all the way up to 8 terms. So a sub 8 is equal to 8 squared plus 1, which is going to give us 65. And then we just have to use the formula again. Okay, so the sum of this guy is 8 over 2, and then times the sum. So 2 plus 65 is 67. So S of 8 is equal to 268 after you multiply that. All right? So that's how you do these first two, which are, pretty easy. The next two, the same type of question, but it's laid out in a different way. So you have to find some other information. Now the cool thing is, in both of these, we have the first term. So we know that a sub 1 is equal to 15 in this first example. But the next thing we're going to have to do is figure out our common difference, because now what we're going to have to do is find a sub n, because we need a formula to figure out what the 21st term is. And I doubt you want to count or subtract 7 until you get to the 21st term. So we're going to use our old formula. A sub n is equal to the first term, and then we have to use our difference times n minus 1. So our difference is we're going to subtract 7 every time. So remember, you can always do like the second term minus the first term, and that'll give you your difference. It's negative 7. So we would have 15 minus 7 times n minus 1. So this is going back to a previous video with arithmetic sequences, finding the nth term. So then a sub n is equal to 15 minus 7n plus 7, which means a sub n is equal to negative 7n plus 22. So now that we have our formula for a sub n, we can just substitute in 21 for n and find the 21st term, because that's what we're looking for, the sum of the first 21st terms. So a sub 21 is equal to negative 7 times 21 plus 22, which means that a sub 21 is equal to a negative 83. So this one requires a little bit of extra work because we have to find what the 21st term is equal to. Now we just go use the formula. So the formula again, sum of the first 21st terms is equal to the number of terms divided by 2. So we have 21 terms divided by 2 times the sum of the first and last terms. So that would be 15 minus 83, which we can then, 83. Now we can just type that in the calculator, and we'll end up with 10.5 times 15 minus 83, and we get sum of the first 21 terms is going to be negative 714. Okay? So that's how you use this formula again when you have to find something else. So I'm going to let you try the last one. I'll just give you a hint. You've got to find your difference. So you can also find how many terms there are. Now, if you'll notice, we have the first term, we have the last term. What you don't have is how many terms there are. So that's what you need to find for this. So go ahead, pause the video, and see if you can come up with it. Okay, so what you should have found is this is going up by 4 every time. So we're going to add 4, we're going to add 4, we're going to add 4. So we're going to add 4, and we'll be at 5, and then 9, 13, 17, 21. So we're at 1, 2, 3, 4, 5, 6, 7, 8, 9 terms for this guy. So we have a sub 1. That's equal to negative 11. And then, like we said, we had 9 terms. So a sub 9 is equal to 21. Now we just have to use the formula. So the sum of the first 9 terms is equal to the number of terms, 9, divided by 2, times the first term plus the last term. So negative 11 plus 21. So that's going to give us S of 9 is equal to 4.5 times 10, which is going to be 45. Okay, so that's it for finding the sum. Now the last question is a little bit different. It's pretty tricky in a way, but once you set it up, it's really not that bad. And this one is finding x to make sure that these three terms are an arithmetic sequence. So here's the thing you have to remember about an arithmetic sequence. An arithmetic sequence has the same common difference between terms. So 3x minus 3 plus d is going to equal 7x minus 32 plus d will equal 2x plus 11. So we're not going to be solving for a d. We're going to solve for x. But what you need to remember is how do you get that difference? So I'm going to go back up to this example right here. We can just say, oh, we need to subtract 7. But if you wanted to find the difference, remember, you could take the second term minus the previous term. That's how you always find the difference. 1 minus 8 will give you a negative 7. Negative 6 minus 1 is going to give you negative 7. So it's the term minus the previous term will always give you your difference. So that's all we need to do here. We just need to take the middle term, 7x minus 32, and subtract the previous term from it, 3x minus 3. And set that equal to our last term, 2x plus 11, and subtract the previous term, 7x minus 32. And now it's just an algebra question. So you distribute, combine your like terms. So 7x minus 3x is going to give us 4x. Negative 32 plus 3 is going to give us a negative 29. Is equal to 2x minus 7x is a negative 5x. And 11 plus 32 is going to give us a positive 43. And now we just solve for x. So we get 9x is equal to 72. So x is equal to 8. Now we know what x is. We can just substitute it in for every one of these, and we'll find out our three terms. Our three terms are going to be 21, 24, and 27. So you can see that they have a common difference of 3. So that's it for Arithmetic Series. This is Longo, and I'm out. See you, bye.